Welcome back to the Deep Dive. Today we're getting into some really cool material science. We're talking about swapping out heavy, non-biodegradable synthetic fibers for something much more sustainable.
Yeah, we're talking about jute, and our mission today is pretty specific. We're digging into research that aims to find the perfect recipe.
The perfect recipe.
Exactly. The optimal weight percentage of untreated jute fiber mixed with an epoxy resin to get the absolute best mechanical performance.
And when you say weight percentage, you just mean how much jute is actually in the final composite material.
That's all it is. It's a simple ratio.
Okay, so let's back up a bit. Why are we even doing this? Why the switch from traditional materials like, glass or carbon fiber?
Well, those materials they're incredibly expensive to produce. They're also an energy nightmare. And at the end of their life, they just sit in a landfill. They don't break down.
So that's where these natural fiber composites, or NFRPCs, come in.
Right. Jute is just a fantastic alternative. It's low density, so it's light. It's widely available, especially in Asia. And it takes very little energy to process. We're talking a much, much lower carbon footprint.
But it's not perfect, right? There's a known challenge with using jute.
There is. Jute has a lot of cellulose, which gives it great stiffness, but it's also hydrophilic.
Meaning it loves water.
It loves water, and that moisture can really weaken the bond it forms with the resin. So this study tried to overcome that just through careful processing using a technique called vacuum bag molding with a high-strength epoxy.
And they tested different amounts of jute.
5 different amounts. They started at 5 weight percent and went all the way up to 25.
Okay, and this is where it gets really interesting because the results, they sort of defy what you'd intuitively think.
They absolutely do.
Across all the major tests, tensile strength, which is pulling resistance, flexural strength for bending, hardness, the best performance wasn't at the highest amount of fiber.
Not at all. The sweet spot, the optimal balance of all those properties, was consistently found at 20 weight percent jute fiber, the JF20 sample.
Give us a sense of that improvement.
Sure. So the tensile strength jumped from about 65 megapascals at 5% all the way up to a peak of 95 at that 20% mark.
Wow.
And flexural strength saw a similar huge jump, peaking at 150 megapascals. That is just impressive performance from a lightweight, eco-friendly material.
So if 20% is that good, why not just add more? I think most people would assume that more reinforcement means a stronger final product.
And that's the fascinating part of this whole thing. When they pushed it just a little further to 25%, all of those properties started to drop off.
They got worse?
Yeah, measurably worse. Tensile strength fell back down to 90, flexural strength to 145. It's a clear case where more is not better.
So what's happening on a structural level? I assume to understand that we have to look much, much closer.
You have to look at the microstructure. In the scanning electron microscopy, the SEM analysis, it tells the whole story.
Okay.
At that 15 to 20% range, the images show everything you want to see. The fibers are spread out uniformly, and the resin has completely coated them. You get this really strong bond.
And that lets them transfer stress effectively?
Perfectly. It lets them bridge any potential cracks. But at 25%.
It's a different story.
A completely different story. The SEM shows the fibers starting to clump together. It's a process called agglomeration. And because they're bunched up, the resin can't get in and wet them properly.
So you get voids, see?
You get tiny voids and weak spots. It's like trying to mix too much flour into dough. You just get clumps. And those clumps become sites where stress concentrates and failures begin.
So the takeaway for you is pretty clear. That 15 to 20% jute epoxy composite, it has some serious potential for lightweight, eco-friendly parts.
Oh, absolutely. Think about automotive interior panels, door trims, even structural laminates. It's a proven, sustainable alternative that's ready to go. It's fascinating.
And this research really just established a baseline, and that was for untreated jute fibers. So it leaves you with this one final provocative thought.
Which is?
If you can get these kinds of impressive results with untreated jute just by using a controlled fabrication process, how much further could you push the performance by adding a simple surface treatment like an alkaline or saline wash to fight that moisture problem and make that fiber to resin bond even stronger? Something for you to think about.